Hi, this is Tori Wheelt with the Oracle Technology Network. We're here at JavaOne India speaking to members of the Java community. I've got Willlam Louth with me here. Hey, William.
Hi, Laurie.
How you doing?
Good, Laurie.
Good. So tell me your role in the Java community.
Well, I'm CTO of a company called JInspired, and we do application performance monitoring and management. And I mainly, my job is to research into new technologies that will help make systems more self-managed, self-regulated. So I'm more focused on that on a quite a large scale. So we have customers with thousands of JVMs, and they want a solution that can manage it. We feel, our view is that this kind of management has to be put directly into the applications rather than something external. So that's what we're looking at, adaptiveness that goes above what the hotspot does today. So the JVM is a very adaptive engine, but our view is that the adaptiveness has to move up into the application tier, and that's what we're focused on. It's research, but hopefully the usage will be soon.
Okay, so tell me, I know you were accused of blowing a few people's minds today, right, as a part of your session. So tell me about the title of your session and generally what it's about.
Yeah, so I had two sessions today, and the first one was signals and boundaries. And this session was focused on how can we create a mechanism that will allow the machine to learn about itself. Today, what happens is when we measure, a solution is an application is monitoring itself. It has a metric, and it publishes the metric, and some other management tool is collecting that metric and storing it in a database. The problem is that the application could probably use that data to help change its own behavior. So what we're trying to do is create a feedback loop that doesn't just notify observers, but notifies itself. So take an example like a typical web app, where a web application goes to a database to make a request, servicing a web request, and the database is not there. And it throws an SQL exception, the exception goes back up to the request, and the next one comes back in, and the application will do the same behavior consistently until the database comes back up. Now, humans wouldn't do that, because we would probably say, well, the database is probably not there, I'm probably going to wait a little bit longer before doing that. But software has no memory, and it has no means to control its behavior. So we're looking, so the signals and boundaries today was how can we make how can we bring intelligence into the application that goes beyond the algorithm itself, but that goes up beyond what do I do, how do I do it, how do I evaluate. So intelligence is about looking at your past behavior, assessing it, and changing your future behavior. This is how we feel intelligence. Like you're smart because you had past bad experiences and you look smarter. So what we're trying to do is make the application. So signals and boundaries was about that, and how we can augment the Java platform libraries to bring signals in. Now signals is kind of like, is basically a kind of a name and a number, like a wave. We call it like a wave. And what we want to do is, if you take light for example, is color is not something that's there. There's a wave, electromagnetic wave comes over, and our eyes interpret it and turn it into a color. So what we want to do, what we view is that same kind of approach can be used for applications where the applications and the libraries have a signals inside them, internal, their names, and they emit them. So today when we write Java code and we call a method, there's one return value. It's the result of the function. If we talk about function, of course you can have a procedure that doesn't do anything. It does something but doesn't return. But what we miss is that, like if we're having signals in humans, when you talk to someone, you're reading, you're looking at whether they're interested, and you probably stop talking when they're not interested, even though the interaction is still there. So we're adapting to those signals, which are beyond just the words themselves. But Java or most programming languages don't have this means to communicate this. Okay, I did this, but really that took longer because of this, or that was a slow way. I had to go a slower way because of this, some data structure or some context. Like if we talk about hash map has a function called get, where you give it a key and it returns a value. Now to do that, it has to turn that into a hash code. It takes your key, turns it into a hash code, looks up a table, kind of an index, and then on that there's a kind of a linked list, and it scans along it. Now occasionally, of course, what you want is that it always hits the first entry and matches it. But what happens if all the keys are hitting the same bucket, and we scan all the way down, and it takes one 1 million times to compare. Well, the
Right.
reason the hash map get was slow was because it's scanned. But when it returns the value, it doesn't tell us that. Unless, of course, what we could do is we could measure it, but if we measure it, then we perturb the response for all the other calls, which are normal. So, because hash map get is quite a quick call. So you wouldn't want to measure that. The time in measuring it would be greater than the time of doing it. But there are these occasional times when it does happen. So we want the software is the hash map in Java to have a signal that emits that says, I did a link scan and I did this amount of comparison. Now, it won't change what's returned, but if the caller is aware, signal aware, he can check the signals and say, what were the signals emitted during that interaction, and he can compare those signals with normal operation, and one of those signals will go off on it, and that's a wavelength. So so think about the spectrum of colors. I will see a different color and a stronger, stronger hue, or and so I'll be able to say, okay, every time it goes a bit slower, it's because of this particular signal. So that's what my mind will do. So an observer we're associating the signals to colors. So I want is all code to be able to observe other code that it's executing when it delegates it, and then to take those signals and turn them into something that says, I'm going to learn from that. Now, of course, the first part is, okay, it would learn at least what's happened. That's one, but that's not really changing. That's not changing a system.